Introducing Calculus Vectors, MCV4U. This course advances students' proficiency in functions and their grasp of rates of change. Students will tackle problems involving geometric and algebraic vector representations, as well as the portrayal of lines and planes in three-dimensional space. Additionally, they will expand their comprehension of rates of change to encompass derivatives of polynomial, sinusoidal, exponential, rational, and radical functions. This acquired knowledge will be applied to model real-world connections. Students will further hone their utilization of mathematical procedures integral to excelling in senior-level mathematics. Geared towards students aspiring for careers in science, engineering, economics, and select business sectors, this course caters to those needing to enroll in university-level calculus, linear algebra, or physics courses. Aligned with the Ontario curriculum, Grades 11 and 12, Mathematics 2007, this university preparation course carries a credit value of 1.0. The prerequisite is MHF4U Advanced Functions Grade 12 may be taken concurrently. This course is comprised of 4 units and a final assessment as follows. Unit 1, Introduction to Derivatives, 26 hours. In this unit, students will address activities related to rates of change and the concept of limits. The unit will briefly delve into the correlation between a secant line and a tangent line to a curve to deepen the exploration of the concept of a limit. While students have previously concentrated on determining the tangent slope at a specific point, this section will introduce the process of establishing a tangent slope function, paralleling this with a secant slope function. The concluding aspect of this unit will focus on sketching the graph of a derivative function. Unit 2, Applications of Derivatives, 27 hours. In this unit, students will tackle a variety of specific problem types, including Pythagorean theorem problems, like ladder and intersection problems, volume problems, often related to filling or emptying 3D shapes, through problems, shadow problems, and general rate problems. Unit 3, Introduction to Vectors, 27 hours. This initial unit of the course delves into 4 fundamental topics. First, students gain insight into the distinctions between vectors and scalars through a comprehensive introduction. Following this, an exploration of vector properties provides a deeper understanding, leading to an examination of vector operations. The unit culminates in an in-depth study of the properties associated with plane figures, emphasizing the practical applications of vectors in geometric contexts. Unit 4, Lines and Planes, 27 hours. This unit begins with students learning how to find the vector, parametric, and symmetric equations of lines in R2 and R3. Additionally, students will also explore determining the vector, parametric, symmetric, and scalar equations of planes in 3 space. The curriculum will also delve into the concepts of intersections between lines in 3 space and the intersection of a line and a plane in 3 space. Students will develop problem-solving skills for determining the intersections of 2 or 3 planes by solving systems of linear equations with 3 unknowns. Furthermore, students will cover matrix-related terminologies such as addition, subtraction, and multiplication. They will adeptly solve systems of linear equations involving up to 3 unknowns by using row reduction of matrices, both manually and with the assistance of technology. An important focus at the end of the unit will be on understanding how row reduction of matrices creates new linear systems that are equivalent to the original. These topics form the key components of this unit. Exam. Final Cumulative Proctored Test. The Final Cumulative Proctored Test, constituting 30% of the overall course grade, spans 3 hours. This comprehensive assessment serves as the culminating evaluation, meticulously encompassing diverse elements of the course curriculum. Significantly contributing to the determination of the student's final grade, the exam rigorously evaluates the student's understanding and application of the course materials. It is a pivotal component in assessing the student's academic proficiency and mastery of the subject matter. Necessary student resources. Device for uploading handwritten or hand-drawn work, e.g. scanner, smartphone camera. Laptop and/or personal computer. Recommended with Google Chrome or Mozilla Firefox. Access to video recording and scanning for handwritten work. mobile phone, tablet, iPad, webcams. Reliable internet connection. 1. Non-programmable, non-graphing scientific calculator. Overall expectations rate of change. By the conclusion of this course, students will be able to understand the concept of rate of change by linking the average rate of change over an interval with an instantaneous rate of change at a specific point, utilizing secant and tangent slopes and the concept of limits. Plot the derivatives of polynomial, sinusoidal, and exponential functions, establishing connections among the numeric, graphical, and algebraic representations of a function and its derivative. Validate the rules for determining derivatives through graphical and algebraic methods. Use these rules to calculate the derivatives of polynomial, sinusoidal, exponential, rational, and radical functions, as well as simple function combinations, and effectively solve associated problems. Derivatives and their practical applications. Upon completion of this course, students will be able to establish graphical and algebraic connections between the fundamental characteristics of a function and its first and second derivatives. They will apply these connections in curve sketching exercises. Additionally, students will solve various problems, including optimization challenges that necessitate the application of derivative concepts and procedures. These problem-solving scenarios may arise from real-world applications and may involve the creation of mathematical models. Geometry and algebra of vectors. After this course, students will exhibit proficiency in comprehending vectors in two-dimensional and three-dimensional spaces through their algebraic and geometric representations, understanding their practical applications. They will be adept at performing vector operations in both two-space and three-space, utilizing the properties of these operations to solve diverse problems, including those encountered in real-world scenarios. Additionally, students will be able to differentiate between the geometrical representations of a single linear equation or a system of two linear equations in two-space and three-space, identifying various geometric arrangements of lines and planes in three-space. Furthermore, they will be skilled in representing lines and planes utilizing scalar notation. Assessment strategies. Assessment for learning plays a significant role in shaping student learning by reinforcing the relationship between assessment and instruction while also offering continuous feedback to students. This type of assessment is integrated into daily teaching practices, enabling teachers to gain insights into students' needs and encouraging active student participation in both learning and assessment processes. Through this feedback, teachers can adapt their teaching methods to better cater to the requirements of their students. The key characteristics of assessment for learning include: 1. It is ongoing. 2. It is directly connected to learning objectives. 3. It provides valuable information for teachers to plan and structure their instruction. 4. It enables teachers to offer immediate and detailed feedback to guide student learning. The ultimate aim of assessment for learning is to cultivate self-regulated and lifelong learners. Report card. Official communication of student progress is facilitated through the issuance of report cards. These reports are distributed at the midterm and upon completion of the course, evaluating two primary areas of student achievement. Firstly, the degree to which curriculum expectations have been met is presented as a percentage grade, with the course median also provided in percentage format. The teacher will include written feedback on the student's strengths, areas for improvement, and suggested next steps. Secondly, the assessment of learning skills is categorized as needs improvement, satisfactory, good, or excellent. The report card will indicate whether an OSSD credit has been attained. Upon course completion, York High School will forward a copy of the report card to the student's home school, if in Ontario, where it will be appended to the student's ongoing Ontario student transcript. Additionally, the report card will be mailed to the student's home address.